So hi, in this video I'll be explaining about what is drag and its importance and its types. Drag is the force that resists the motion of an object through a fluid, like air or water. Imagine running your hand through a water, you feel resistance. In aviation, drag is the enemy of efficiency, slowing down the aircraft. Overcoming the drag requires energy, which means burning more fuel and increasing the costs. Engineers work tirelessly to minimize the drag, making the aircraft faster and more efficient, environmentally friendly. Parasitic drag is the resistance an aircraft experiences due to its shape and surface. This drag is a significant factor in the design and performance of any aircraft, affecting its speed and fuel efficiency. Parasitic drag has three main components: form drag, skin drag, and interference drag. Each of the components plays a crucial role in overall aerodynamic efficiency. Form drag is caused by the shape of the aircraft. The more streamlined the shape, less drag it will experience. Streamlined shapes create less drag. This allows aircraft to move more efficiently through air. Skin drag is caused by the friction between the air and the aircraft surface. Friction can slow down the aircraft, reduce its efficiency. Even a smooth surface creates some friction. Engineers work to minimize this using the special materials and coatings. Interference drag is caused by the interaction of different airflow patterns. This type of drag can particularly challenging to manage. Profile drag is a type of parasitic drag related to the shape of an object moving through the fluid. It's like an airplane wing. It combines form drag and skin drag. Streamlined shape minimizes the profile drag, while blunt shape increases it. Induced drag is a fascinating type of drag that is inherently linked to lift. It plays a crucial role in aerodynamics. As an airplane generates lift, it also creates wingtip vortices, which is spirals of air trailing from wingtips. Induced drag is a drag penalty associated with generating the lift. It increases with the amount of lift produced.
Hello everyone. Today we are going to see about a very important topic in the flight dynamics. Before we jump into the topic, we all should know about the aerodynamic forces involved in a flight. There are four aerodynamic forces. The first one is lift. Lift is a force produced to oppose the Earth's gravitation and makes the flight fly in the air. And then the second force is weight. Weight is an opposite force that created by the weight of the aircraft, which is pulled by the gravity to oppose the lift. And then the third force is thrust. Thrust is a force which is given by the propellers or the engines to make the aircraft move forward. The fourth force is the drag. Drag is the force that opposes the thrust of an aircraft, which opposes the forward motion of the aircraft. So that these are the four forces included in the aerodynamic forces. And then coming to the topic, what is level flight condition? An aircraft is said to be in level flight condition when the four aerodynamic forces, a lift, drag, and weight and thrust, all are balanced equally. In the level flight condition, the four aerodynamic forces are balanced equally. And then talking about steady flight condition, steady flight condition is a condition during it causes during the level flight condition. In the level flight condition, there is no acceleration takes place, and then the linear and angular velocity of the aircraft is said to be equal. It is called the steady flight condition. A level flight condition is a type of steady flight condition. We should be clear about that. And then that's all about it. I think you have gained a knowledge about the steady flight and level flight conditions, and also the aerodynamic forces of flight. Thank you for watching this video. Thank you.
So, good morning, everybody. Today we are gonna see about spiral divergence or spiral instability. What is mean by spiral divergence or spiral instability? It is a condition of aircraft where there is a high directional stability and a low lateral stability. So, it is characterized by low angle of attack. When the lateral equilibrium of an aircraft is disturbed by a gust of air, the bank angle is disturbed and a side slip also introduced, let's say. So the strong directional stability tends to yaw the nose into the resultant relative wind speed direction, and the comparatively low or weaker dihedral angle tends to restore the lateral stability. So due to this yaw, the outside wing is turning moment travel forwards faster than the inside wing. Due to this, as a consequence, the lift is becoming higher. This produces an overbanking angle tendency, which is not corrected by the pilot, is becoming steeper and steeper. At the same time, the strong directional stability that yaws the aircraft into the relative wind speed, actually forcing the nose to lower the pitch altitude. A slow downward spiral begins in this step. So let us take an example of spiral divergence. Let's consider a larger finned aircraft with no dihedral. In this case, the bank and the side slipping and the side force tends to turn the aeroplane into the relative wind speed. The outer wing, as I said before, is travel fast than the inner wing. This generates the higher lift. So the aeroplane will roll into the side of the wind. With no lateral stability in present to negative, this negotiate this roll, the bank angle will increase and the aeroplane continues to turn into the side slip in ever tightening spiral. So let us take an visual view. So this is the initial path, and the insufficient directional stability, which tends to the directional divergence. The airplane may broadside yaw into the wind. Then excessive directional stability and poor lateral stability makes a spiral diversion. That is, the bank angle is increased and causes greater and greater side slip. So the airplane disturbance introduced this due to the high directional stability and low lateral stability. Thank you.